Hello, this is Zhou Lu, and this video is made for probability and stochastic processing courses. Question 1 in homework 6. And let's look at question 1. Question 1, we have that x and y have joint density function. And the function is 1 plus x times y divided by a. And we need to, that's absolute value of x is more than 1, and the absolute value of y is smaller than 1 too. Okay, so question 1, we need to find a so that the above defined is a valid joint density function. So it's easy. We just take double integral of the joint density function of x and y, and the answer must be 1. So this can make the joint density function valid, and the answer is 4 divided by a, and just as I said, need to be 1, so a is equals to 4. Question 2, we need to prove that x and y are uncorrelated or not uncorrelated. Okay, we just calculate the mean of xy, the mean of x, and mean of y, and I just times the mean of x and mean of y, and we compare it to the mean of xy. If they are equal, they are uncorrelated. So we just firstly we calculate the mean of xy. Use double integral, and xy times the density function of xy, double integral. Okay, answer is 1/9. The mean of x, also double integral. This time we use x to times joint density function of xy. Okay, answer is 0. So actually we don't need to calculate mean of y anymore, because the mean of x is 0. We know that 0 times any value still to be 0, so it can be 1/9. So now we know that the mean of xy is not equals to mean of x times mean of y. So which means xy are not correlated. Okay, question 3. We need to to judge that are x, y independent? Actually, we in question 2 we know that x, y are not uncorrelated. So x, y are not independent. Because this can get this. If x, y are not correlated, x, y must not be independent. Let's see question 4. We need to find the joint density function of x squared and y squared. Okay, in this question we need to use auxiliary variable method. With that, z be x squared and w be y squared. Now we calculate j. J here is we take a derivative of xy, and this is equals to 2x 0 0 to y, right? 2x derivative of x is 2x, 2x derivative of y 0, y squared take derivative of x 0, y squared take derivative of y dy. This is equals to 4x times y. Okay. This time we need to calculate the answer of x, y in the form of z and w, but this time z is equals to x squared, w is equals to y squared, which means if we want to calculate x, y, we have 4 roots, square, so minus and positive and negative, and so x and y both can be x positive and negative, so there are 4 roots, right? 4 roots. So we just calculate them one by one. Okay, when z is larger than or equal to 0, smaller than or equal to 1, and same as w. So j is this, and this I can be 1, 2, 3, 4. So the joint density function of z and w is is this. 4 rows, so 1, 2, 3, 4. Just as I say, xy can be positive and negative, so positive, positive, negative, positive, positive, negative, and negative, negative. Therefore, different conditions we need to calculate. Therefore, okay, and the answer is this. Okay, firstly we think about it, calculate this condition. And another condition is z smaller than 1 or z above 1, and so do w. This the joint density function is 0. Okay, let's write the answer again to let the answer more specific. And actually we know that the density function of z and density function of w. Okay, we calculate the density function of z, and thus density function of w is, in order to fix the question 5. Question 5, we need to judge that x squared and y squared are independent or not. No, we see that the joint density function of z and w is equals to density function of z times density function of w. So z and w are independent, and z is equals to x squared, w is equals to y squared. So x squared and y squared are independent. Sorry. And that's all. Thank you.